Hey guys, welcome back to my channel, and welcome back to another episode in the saga of the Terex Manlift. So last episode I basically had reinstalled the box after fixing a lot of the wiring issues I found wrong in there, and I found a bad micro switch on the boom extension control. And I was very pleased to find that now the boom extension control works. However, I still have a remaining problem, which is what's keeping me from being able to use this machine right now, which is that it will not swing left or right from this control. It will still swing perfectly fine from the base controls, but that's not going to do me much good when I'm up in the air working with this thing. So I've got to figure out what's going on with this. Since the last episode, I have learned quite a bit about the technology that's involved here, and needless to say, I'm not pleased with what I learned. So the guys who developed this thing down in Connecticut, this company, OEM Controls Inc., down in Connecticut, are the ones who are responsible for this. To me, it seems like they made this thing a lot more sophisticated than maybe it needs to be. Maybe I'm wrong. I'm not an engineer, but needless to say, those... Well, I didn't count on that noise being out here. We're putting up new guardrails down the street over here. So anyways, I went to the EEV blog webpage. On that webpage, there is a forum section. And in the forums, that's a great place if you've got questions regarding electronics where you can go. There's a section for beginners. And anyways, what I did was I wanted to find out what that mystery device was, that thing that actually looks like a potentiometer, but it's not. So I ended up going on there and posted a picture of it, explained what it was being used for, that it was on the joysticks in this thing, and sure enough, right away, several guys responded and were able to tell me. Some of them took a guess, and they knew exactly with the guess what it was, and some of them zeroed right in on it. But what it is a, I believe it's called a current source loop sensor. I don't know. I don't remember exactly. Long story short is that device is in series with a circuit that when that device is manipulated, it will vary the current flow in the circuit. And that varied current flow will be interpreted by the digital controller and turned into the output pulses that are required to drive the hydraulic relays. I also learned that there are two little LEDs on each one of those devices, and each one of those LEDs is supposed to light depending on which direction the thing is being rotated. As we already know, they're already in series with micro switches. So when nothing's being touched, the micro switches are open, and those things are not under power. They have no power. When the micro switch closes, that applies the 12 volts to those devices, and that's when they start going to work. One of the best things I was able to get from somebody off of the EEV blog in answer to my question was they were able to actually find me a manual for the controller that's inside here, the Superflex 4 board, or whatever the heck those guys at the company decided to call this thing. So this is the SB10 Superflex bus, okay? And then down there in the main base unit, that's where the main controller is. So here's the back of one of these digi sensors. This happens to be the one that I put the new micro switch, the joystick for the boom. That's the new micro switch I put in. And there's the digi sensor. And these two bumps right here that I didn't even realize what they were before are actually LEDs that are potted in there. So when I actually actuate this thing, those LEDs should actually move. Now what I'm not sure about is whether or not, if I turn the key on and I just send power to the system, whether or not I can actually make these LEDs light by moving that without the engine running. So let's try that for the heck of it. So I've got the power on, the key switch on down at the base, and I don't have the key switch on up here yet, but already I must have power coming up to here because you can see these two LEDs are flashing like crazy. This one is marked CPU. So what that's telling me is by that flashing, according to the manual that I was given by the person online, that would mean that the CPU is running. If that was solid red, then it would mean a CPU failure, which would be bad. Then the other one here that's flashing is the bus one, or is it? It's funny, it's blinking, it looks like it's flashing very dimly. And then there's one that's lit solid over here on number 2, which is interesting. So I don't know, is there an LED on, yeah, there's an LED on every, there's an LED on every one of these and every one of these. So if I had to venture a guess, I'm guessing BT3 and BT4 are the input and output. Well, actually this says BT5 outputs. BT4 inputs function, so these are the inputs. BT3 are also inputs. So it looks like number 2 has an input going to it right now, even though I'm not doing anything. All right, maybe I have to have the key on. Not the key, but the ignition switch up here on. All kinds of lights going here now. All right, no matter what I do, no matter what joysticks I move, nothing seems to change over here. I would think that these would light up as it receives inputs. If I unplug this, oh, hold on, let me see if those LEDs light when I move these. No, they don't. Okay. So the LEDs on the digi-sensors don't do anything. Nope, doesn't matter. I think I'm gonna have to start it up. Oh, I keep forgetting I'm not stepping on the foot switch. Put my hand over there, shade out the sun so you can see these LEDs. They don't do anything now, but when I hit the foot switch, those light. And so do the ones on the joystick that's not working, the one that does the swing. So that tends to indicate to me that voltage is getting to this digi-sensor on the joystick for swinging. So now I just shut it off. I want to see whether or not I can get this to light. No, let's see. Oh yeah, okay. Those actually will light as long as I'm pressing the foot switch, even with the engine not running. So if I want to do diagnostics on this thing with the engine not running, it looks like I can. So the other thing that I learned from reading the manual that I was given is that the way to properly troubleshoot and diagnose problems with this system is with a special tool called an optimizer. There's actually a port, I think it's down on the main unit, on the main controller, the Superflex controller. There's a port that you plug in this box, and it's got an LCD readout, and basically it will be able to do all kinds of things for you. So the problem is, if you're not a dealer, you're most likely not going to own one of these things. I think even if you can find a used one for sale, they're crazy money. Definitely not worth the kind of money that I would want to invest. It's the kind of thing you're only going to buy if you're going to be in the business of fixing these for a living, I guess. Well, so my thinking was that this bus light shouldn't blink unless there's actually activity on the bus data line. And I wouldn't think there'd be activity until you were actually wanting to do something. So then I thought, well, maybe this LED number 2 being on all the time, maybe that's like some logic state that's stuck high or something, right? And maybe that's my problem. But number 2 goes to this wire, which is wire 306. And wire 306 actually goes up to the key switch up here. So I certainly don't think that's the answer to my questions here, because essentially what that's going to do is, well, what is that going to do? I guess the point I'm making is I think that's normal for that to be on. I got a feeling that 306 is going to be one of those wires that if I go back and look to the wiring diagram that I found online, I'm not going to be able to find it even. Well, I went in and looked at the diagrams that I have, and that wire, I think it was 306 or whatever, I did find it. It does go to the key switch just like it's supposed to. Then where it goes on the other side of the key switch, I'm not sure. It seems to go back down here to the control box. But the point is, I think that's not going to be my problem. I think by design, that's probably supposed to be an input that's always on for whatever reason. At least that's all I have to go on for now. This is just a real crapshoot here trying to figure out what's going on. So now I've decided to turn my attention to this lower unit. So this is the Superflex 4 controller, and there are 3 LEDs down here on the bottom, and the middle one is the CPU, the left one is the input, and the right one is the output. So I think if I understand kind of how this works, that bus up there, that board up there in the aerial unit is a transmitter, and what that does is that sends signals it receives from those joystick controls down here to this board, which is the receiver. And then I think the receiver will then send that over to the controller over here. So that's all I have to go on. So I figured, just for the heck of it, I want to see what these lights do when I activate things up there. Now, unfortunately, I can't be in 2 places at once, so I'm going to basically have the camera down here, and I'm going to have to actually review my own camera footage to see what the heck's going on. So now I've zoomed in on these 3 LEDs, and let's see, we get the key switch, get that key switch on. A bunch of lights over here come on, start flashing. Unfortunately, I don't have any information about this board or the board up in the upper unit. Well, some other lights on that board up above are flashing and on, but I don't really have any information about that unit, so not much I can do about that. Well, that CPU light isn't blinking. That's not good. All right, so what I did was I went up there and I stepped on the foot pedal, and then I operated the boom extend and the boom retract, and it worked. Then I released the foot pedal so it idles down, and then I stepped on the foot pedal again, and then I tried the 2 swing modes. Swing left and swing right. Swing left, it started to just barely move, which it's been doing that, but then swing right did absolutely nothing. But I'm wondering what happened with these lights while I was doing that. So let's see. And then the last thing I did before I shut it down was I actually actuated this toggle switch down, held this spring loaded, which then puts these controls in play, and I operated those toggle switches to see what happened, because it does swing from down here. So now I'm going to review the footage and see what it did. Well, I just played back that video and got to see what you guys already saw, which is that turns out the CPU doesn't start running, apparently, until you press the remote switch, the foot switch up there. So as soon as I stepped on that foot switch and it idled up, that's when the CPU light started blinking. Then when I did the boom extend or retract, the input and the output LEDs flashed. So that tells me it was receiving a signal and it was outputting a signal. And then when I retracted it, did the same thing. Then I went to the swing control that's not working. And guess what? It did exactly the same thing. It lights the LEDs in the same way, which tells me I'm barking up the wrong tree. I don't have a problem up there in the basket, I don't think. I think that those controls are actually working and doing what they're supposed to be doing. They appear to be sending their appropriate signals down here to this controller. And not only that, but the controller appears to be sending outputs. So I've got a problem where, for some reason, the outputs aren't actuating the solenoids, the hydraulic solenoids. So very interesting. Also, I noticed that when I use this switch here to use these toggle switches up here to control it from the base here, nothing happens on that board. And my theory is that all of these switches up here, these toggle switches, are just direct wired after the outputs of the board. In other words, by design, I think what happens is that board doesn't do anything when you're using these controls down here. But this is actually some good news, I think. Well, for one thing, I know the CPU's working. I kind of figured it must be working because the boom works, it drives, it does all this other stuff. So if the CPU was dead, I would think I'd have no control from the basket whatsoever. All right, it's starting to get a little dark, so I'm going to call it quits for today. I'll do some more head scratching and looking at diagrams and seeing now that I'm going to try and concentrate my efforts on what's going on down to this box. Go from here. Oh, and I got to mention it again in case you guys saw it and will wonder, well, what's that wire? I still have this issue of, kind of hard to get in here with the door in the way, but this wire right here has this connector on it. This was just hanging in here like this. And I don't think it's supposed to be. The problem is the wire number on here is clearly 413, I think. Yeah, 413. I can't find wire number 413 anywhere in the diagrams that I have. To make matters worse, since it's bound together with this, everything would indicate to me that it's supposed to go to this plug right here. The problem is, if I take this plug off and look at it, it actually has 10 wires already in it. Meaning the only two open ones are the two top ones, which according to this are pins 1 and pin 7. The problem is, when I look at the diagram that I have for this board, it actually does not show anything hooked up to 1 or 7. And it actually also doesn't show anything hooked up to a couple others down here, I think, that actually do have wires in them. So I'm kind of at a loss as to what that is. All right, so it's a day later. I've had some time to sit down at the computer and look at the plans, the diagrams, try and figure some stuff out. A lot easier to do it on the computer, especially when you've got older eyes like I do. Anyways, long story short, as if I ever tell a long story short, I think I have enough information to diagnose this problem now. Let's start with the diagrams. This is a blown up section of one of the diagrams that was offered in the manual that I have. And basically it's showing, this is the whole valve assembly right here, which is this puppy right here. So this is where the hydraulics actually and the electrical actually meet. We've got all of these solenoid valves that are actuated by voltage going into them. These are proportional valves, so the more voltage that goes into them, the more they open up, the faster things move. So if we look at the diagram, it shows us that all of the wires for actuating all of these valves, no matter what job they do, they all end up going through a bundled cable, which is I think what they're apparently trying to represent by this here. And then more importantly, it interfaces right over here into this box, which, notice it says at the top, C connector. So I blew up just this section of the diagram to help me be able to read it easier. So what got cut off is that this box right here that you can just see the two edges of, this box actually says ground control. So what that means is that they're talking about right here, the C connector is the main plug going into the control box from this valve. And from this valve we have just this one really big cable, and that goes over, mixes with another harness, and ends up coming over to here and goes into this big connector right here. So this must be the C connector. And that makes sense, because I know this big connector is coming from the aerial platform, because it's got this big ribbon cable that actually goes up the boom. So this must be my C connector. So if I look at this diagram, I can see that the two valves at the very top in this picture, the one this one right here, and this one right here are basically labeled turret rotation, clockwise and counterclockwise. And for our purposes here, I'm mainly concerned with these two wires, 18A and 8A. 18A is current turret rotate clockwise, and 8A is turret rotate counterclockwise. And those correspond to C12 on connector C and C23. So that would mean pin 12 and pin 23 on this big connector. So here's the diagram for the ground control station. This up here is the actual PC board, the SupraFlex 4. This connector right here is BT3, which is the output connector. So here's my board, and sure enough, outputs BT3. And it even has a little diagram telling you that, oh, okay, look, this is going to be solenoids are going to be powered by these outputs. So looking back at the diagram, all of the outputs wires from BT3, the plug BT3, actually come down here into this mess. Here's an exploded view of the section where the BT3 plug is, so that I could get a good look at the pin numbers for that plug, and they're pin 8 for rotate right and pin 18 for rotate left. And then I followed those down. I blew up this section of the diagram that I just called the mess. And if we look down here at the bottom, you'll notice it says turret rotate right, turret rotate left. Notice it says C12 and C23. So that's the output to the connector. In other words, these points right here are actually where these wires go into the back of this connector. So we should see a wire designated 8 and a wire designated 18. So it looks like the wires are going to be 8 and 18. Now I can rule out anything from the output of this connector over to the valves themselves and the valves. Why? Because I know that it operates from the ground control toggle switches. So how does that work? Well, the way that works is there's a splice. This is one of the wires coming from BT3, and this is one of the other wires coming from BT3. They come down here to this splice. On the other sides of these two splices, it goes over to this, which is the toggle switch for turret rotate right or left. And what they're doing is they're just sending 12 volts on wire 23 to the common contact, so the common connection on this switch. And then when you push the spring-loaded switch one way, it sends 12 volts to 8. You push it the other way, it sends 12 volts to 18, and that will make it rotate left or right. So the other thing that they do, which is interesting, is right up here is the aerial / ground switch. This is the spring-loaded switch I have to hold down to make the ground controls work, and that's indicated by this spring right here. That's telling me that normally it's in this position, which is the aerial position. That wire over there is going to go over to the aerial station and send 12 volts to the aerial station. When you pull this switch down, what happens is the 12 volts coming in on 33 is now cut off and basically kills power to the aerial station and sends that 23 volts down this line here and making these toggle switches now active. So since I know that I can rotate the turret from the ground, what that tells me is that this turret rotate switch is working perfectly fine. Not only that, but the 12 volts that comes out of this switch when I activate it in either direction has to be able to go through this wiring and get to these two pins on this plug. Otherwise it wouldn't work at all. Which means my fault has to be that the 12 volts is not coming in from the Superflex board at these points right here and here. So what I need to determine is whether or not there's a problem with the wiring between here and the board. If there isn't, then unfortunately it means even though my board is saying that it's sending output to those two pins, that nothing's coming out of those two pins. So I've unplugged BT3, and I know that after these two blanks, that wire right there that I've got my finger on is 18. And I traced it, and sure enough it goes up to one side of the toggle switch for swing left and right. And then it comes out of the toggle switch and it goes on and eventually goes down to that C connector. So all I need to do is pull this off here, and I want to check continuity between here and that pin for right there, and I should have continuity. So I've got this wire disconnected from the toggle switch. I've got my jumper wire clipped to that, to my meter. Got my meter set to continuity. Now if I just come here to this plug and I go on that pin, which is pin 18, I have 0 ohms, so I have good continuity there. So unfortunately for me, just checking the actual resistance of that, yeah, it's 0 ohms. So unfortunately for me, it means that nothing's coming out of this board at that pin when I actuate the controls up there in the aerial. Even though we saw that the inputs and output diagnostic lights were flashing like crazy, which according to this chart right here, it says flashing SF4 OK, SF4 OK, SF4. The SF4 is the board. And what they're basically saying is the Superflex is doing what it's supposed to be doing. At least that's what the Superflex thinks. While I'm at it, I'm going to check number 8, even though I have a feeling it's going to be also fine. Okay, so now I've reconnected that other wire, and I've disconnected the wire off the other end of the toggle switch. This is going to be the one that's going to correspond to pin 8 on the plug here. I know that pin 8 is directly across from 18. So since I knew that one there is, so if this is 18, this should be 8. And I'm getting 0 ohms. I was wondering why it wasn't beeping. It's because I forgot that I changed it from continuity to resistance. So that tells me it's not a problem with the wiring, which I kind of suspected because there's really not much here for the wiring. Most of it goes straight through, you know, over to this big cable, which we know the cable's good. So there's something wrong with the Superflex. Well, I think there's something wrong with the Superflex. It's one of two things. Either the Superflex thinks that it's outputting a signal, but it's actually not sending the 12 volts out, or the Superflex is disabling the 12 volts from going out because of some sort of a safety interlock or something that I'm missing out, that I'm not getting. But I don't get it because it's like, well, would all those interlocks be overridden by, well, I guess, yeah, the ground control switches pretty much do override it because the ground control switches are very rudimentary. All we're doing is we're sending 12 volts to the solenoids. So I'm going to see whether or not I can get this board out of here and get it on the bench and just do some rudimentary basic testing, real hunt and peck, flying in the blind type of diagnosis of this thing. In other words, if I'm lucky, I'll find some bad connections on here, which I kind of doubt. Why would both of them be bad at the same time? However, what I might find is there might be some driver transistors or buffer transistors in here in that circuit that are on that output leg that for some reason those have failed. That could cause this problem. So I did find one of these boards online. A couple different places have these boards, supposedly. I kind of wonder whether or not when you actually call to order it, if they would give you the bad news if they don't have it, because they have like prices like $1,800 for this board. What is this wire? Oh, that's nice. What is that wire? A little blue wire right here. It just goes to nothing. Oh, that's spliced into this wire right here. Or it was. They cut it. That's been cut. What the heck? So there's a little blue wire that goes up to a terminal strip up top here. And it comes down, and it was spliced into this wire right here, but it appears to have been cut. If I can try and get the wire number off of that wire, maybe I could find it on the diagram and figure out what the heck that has to do with things. Yeah, I can't see it. It goes to one of these relays. There we go. One not so super flex board. All right, all 4 screws. I don't know how I'm going to get those screws back in. That's going to be tricky because, like I said, I usually would use a magnetic screwdriver to hold them. I think I've got one of those screwdrivers that has those little metal fingers on it that kind of hold screws. I'll have to use that, I guess. Let's pull this relay out. Yeah, so I thought. If I pull the relays out, it exposes these little nuts right here on studs that hold these relays in position. So what I'm wondering is, if I undo those, whether or not I could pull this whole wiring harness out this way and give me a little bit more room to work. All right, back in the workshop. Got this on the bench here, and I'm going to try and take a look and see if we can see any obvious issues with it. I'm going to start by removing these screws so I can take the board off of this metal backing plate, because I want to be able to look at the back side of the board and see if I can see any signs of any corroded or damaged traces. Although I have a feeling I'm not going to see much, because this whole board is coated with almost like some sort of a, it's almost like a silicone coating or something that I'm sure is designed to keep all moisture away from the board. I remember years ago, occasionally we would have problems with certain types of coatings or adhesives used on boards that over time would become slightly conductive and cause problems. Hopefully this would not be one of those types of coatings. Although I would think that we being me and the mouse in my pocket, would be experiencing far more bizarre and unusual problems, or the CPU just not running at all, if that were the case. Oh, okay, there's a plastic coating on the plastic sheet on the back here. Thick plastic. Wow, that's thick. That's interesting. So this does not seem to have the same coating on the back. Oh, this is the coating. I think this is actually the stuff that was poured on the back, and over time it has actually just completely delaminated, for lack of a better term, from the board. You can almost see from looking at the corner here, the shaping of it and everything almost seems like it's just it was poured on. So, okay. So even before I open up this shield on the top, I can already see that all of these things right here look like those little plastic inserts that you put the insert in, and then there's a pin in the middle that expands it. All of these right here are probably to hold the tabs of some larger transistors in place. And those transistors are laying flat this way, I bet. I think the TO220 style package, is that what they would call it or whatever? And then you get three pins, so these are the 3 legs of each transistor. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 transistors going right across here. Since they're on this side of the board, this is probably the this is the output side. Basically, what we've got is we're going to have digital outputs here that are going to be turning on these transistors, and that's what's going to be sending the drive output to actuate the solenoids. So if I'm lucky, 1 or 2 of these are just bad. So how do we open up this cover? Seems like it's just a press fit. Doesn't appear to be soldered. All right, here we go. So I want to make sure I put this on correctly when I put it back together. Well, actually, it's pretty straightforward. The 3 plugs right here are shown on this diagram. So obviously, if it's on like this, it's on backwards. Take that off. Oh, look at that. Oh, there's a lot more going on inside here than I expected to see. Woof. Oh, yeah. Expected to see a CPU, and I would have guessed this was the CPU, except for the fact that there's another one right here that's identical to it. So are there 2 CPUs in here? Got a couple of electrolytic capacitors inside here that I didn't know were in here. I thought that was the only electrolytic on the whole board, actually, but nope. Got one there and an axial lead one there. Got a bunch of Allen Bradley style carbon resistors here. And a whole bunch of heavy looking diodes. And then there's the transistors I was talking about. So it's a little hard to see underneath this coating that's on here, but these transistors right here, they are TO220 packages, and they are marked BUZ11, and that is an N-channel MOSFET. So they're using MOSFET transistors here to drive those relays. So each one of these MOSFETs corresponds to one of the channel outputs. So on here it shows me that pins 3, 4, 5, and 6 are all PWM, which means pulse width modulated outputs. And they're numbered 1B, 2B, 3B, and 4B. And then pins 9, 10, 11, and 12 are 1A, 2A, 3A, and 4A. So that accounts for 8 of the transistors, but there's actually 10. But I noticed that they also have aux2 and aux1. So I'm thinking that's what those other transistors might be. The extra ones might be for these aux channels. I also don't think that they're using all of these for the for this system. I remember that these first 2 pins over here on the bottom right didn't have any wires attached to them, I believe. So those would be pins 1 and 2, which 1 is not connected and 2 is aux2. So what I did was I checked continuity from this pin, which I know is one of the 2 output pins I'm dealing with, and I was able to find out that this resistor right here has continuity to it. These resistors are very low resistance. Their color code is brown, orange, silver, gold. So they're like 0.13 ohm each. All of the resistors are good. I tested those in circuit. And all of the diodes appear to be good. I tested those also in circuit. Now I'm not testing with a curve tracer, so you could have a leaky diode, but I'm just looking for like obvious shorts, nothing to fit that bill. But I have continuity to there, and then that goes through this diode to this pin on this transistor. So none of these other pins on these transistors react. So I feel confident that this is the MOSFET for that channel. And then I know that the other connection was right across from it. So it's this one, which corresponds to this resistor, this diode, this pin on this MOSFET right here. Once I did that, I satisfied myself that these are the 2 MOSFETs I'm dealing with. I then went down the line and I actually compared the measurements with my diode tester on all of these MOSFETs, and they're all identical. So none of these MOSFETs are acting like a bad shorted MOSFET. I'm getting the same readings. So at first glance, it would appear that all of these transistors are good, which makes me wonder whether or not it's not the actual transistors themselves. These MOSFETs might not be the actual culprit. It could be what is supposed to be turning these MOSFETs on and off, which I believe is going to be these little tiny pairs of transistors right behind here. Now I'm making an assumption that the circuit flow is from some of these ICs through these little like buffer transistors to the MOSFETs and then through these devices to the output pins. That's a big assumption to make. What bothers me is there are a ton of very small surface mount transistors all in here, and they're all buried in that goop. So it almost appears as if there's like 6 right below each one of these transistors and then a row of another 6 right here next to it. And that repeats going right down the line. So any one of these little suckers right here could be bad and cause my problem potentially. Same thing with these pairs on the back here. I know from experience I do not have good enough vision and good enough equipment to handle dealing with changing out these tiny little surface mount devices. I will probably end up damaging the board if I try it. So I think at this point I might have to bite the bullet and take advantage of one of the several online service companies that that claim that they offer repair services for these boards. So I think what I'm going to do is probably tomorrow during business hours is maybe call around to a couple of these places. A lot of these shops tend to be actually pretty small shops, and sometimes you can get somebody on the phone and talk to them and get enough information out of them to kind of get a feel for whether or not they really have experience with this board or not. There's a company called Providence Electronics that is not in Providence, Rhode Island, oddly enough. It's down south somewhere. But they seem promising only because they show on their website that they made some sort of a test box that they use on the bench to be able to just plug right into these plugs and analyze whether or not this board is working correctly. As opposed to some of these companies, they'll list random board numbers, obscure PC boards like this, in their listings as boards that they repair. But oftentimes what they'll do is they'll just take the board in and they'll just look for obvious defective components and go about it that way. But that Providence Electronics, they even list right on their website, I think a range of like $375 to $650 or something like that for repairing these boards. So they seem to have a pretty good handle on what it's going to cost to repair one of these, which makes me think that they've done quite a few of these, or enough of them anyways.